Bismillahirrahmanirrahim. Friends, I'm me Muhammad Wasik on your channel Meets Electroworld. Today we are going to speak on the nature of light, what exactly the light is. Although until so far it's confusing to understand completely what exactly the light is, right? Anyhow, we will see what exactly the nature of light is. Till 17th century, we didn't know about exactly the light is a wave or it's a particle. Later on in 1801, Thomas Young performed an experiment in which he used a sunlight beam, a single sunlight beam as a source, and he split it into two beams, and then he passed this from two slits, and he observed the output patterns on a screen. And what he observed, he astonished to see that what he was expecting, light is not behaving in this way. Light was behaving as a wave, right? To understand if light is a wave, then light should follow any other sort of a wave like water waves. I'll show you. There is a pond, right? We have a pond here, right? This is a pond of water pond, right? And I just make two openings over here. There is a source of that generates the water waves, right? And from these two openings, these circular wave fronts are coming out, right? And they simultaneously come out, and these waves are on some places they make the constructive interference, and on some they make the destructive ones. And in this way, on the screen here, or edge of the, you can say, like the pond, what we observe is you can say, like constructive and destructive interference in a particular fashion, right? So in this way we are saying that this is a water is a wave. So if a light is a wave, then light should behave in the same way. And Thomas Young performed his experiment in which this water wave is replaced with a source of light. Then he passed the light from two slits, and he observed the output on a screen, right? So you can perform this experiment easily at home. Before you do it, right, I'll tell you, after Thomas Young, Isaac Newton was also working on the same phenomenon of light, and he come up with a forerunner theory of the photoelectric effect that tells us that light is a particle. And Albert Einstein is, you can say, like he's the one who gave us this photoelectric effect, and he proved that light is energy packets. We call them the photons. So Isaac Newton's theory was the, you can say, like forefather of this photon theory, right? Where Albert Einstein is telling us that light consists of little packets called the photons, and depending on the frequency, its energy is directly proportional to the frequency. E is equal to h mu or E is equal to hf. So in this way, before Albert Einstein, our concept was not clear about this, you can say, like equality. Either energy is directly related with the frequency, or it's related with the amplitude. At that time, people thought that might be, if we increase the amplitude, then wave is more powerful. But that's not the case. Einstein proved with photoelectric effect that if you are shining a very bright red light on the gold leaves, they are not moving from their place. Instead of it, if you can say, like not a very bright light of the blue frequency, right? When you just, because the blue frequency is more has the more energy than the red light, then it will work, and these you can say, like gold leaves will change their position. So that's another experiment anyhow. So anyhow, Albert Einstein proved that light is a particle, and Thomas Young proved that light is a wave. So anyhow, they both are true. In other words, because light itself is very mysterious, so it is behaving like a wave and the particle. We call them the wave-particle duality. So today we are going to repeat the experiment that Thomas Young performed in 1801. You can easily do it at home, right? A couple of things you need for the source of light. I'm using today, this is a laser diode, right? I'm using this one, and you need a little, any piece of you can say, like cardboard piece or anything, right? To make two slits, right? You need a scissor, you need a tape. I got 2 gauges of the copper enamel wire here I'm using. This is the 28 gauge copper enamel wire, right? And this is the 14 gauge copper enamel wire, right? So I'll show you how you make, you can say like slits. It's very easy. Just make a single slit as narrow as possible. As narrow as possible. Make a single slit, right? And then you need to, this is the 14 gauge copper enamel wire. Better you use the other one. I make both of them. I already made 2 slits here. Now cut a piece out of it, right? And then place this piece in the middle of this single slit, exact on the middle. Okay, you try it and fix it on exactly on the middle, and then place the you can say like this scotch tape over here, right? So that's it. You need a little piece of the scotch tape. Just cut it and place it. This is a very easy way to make double slits for the laser beam. So just like this, just place it here. Now your double slits are ready. So in this way you make the double slits. Now I already make 2 slits here. This is the 28 gauge copper enamel wire slit, right? Single opening with a wire in the middle, right? And this is the with the 14 gauge. So I'll show you the results on the screen. So now for this purpose I have to turn off the lights so we can see the you can say like output of this laser on the screen. So lights are just turned off, and now have a look on the wall. I'm just placing this beam, and you see here, you see there is not a single dot that is coming on the output screen. There is a fringe. There's the band of light, dark band and then colored band, then dark band and the colored band, and it is behaving like a wave. That was the Thomas Young already observed in his experiment. Hope so you are seeing the gaps between you can say like these repeated patterns, and this is the constructive interference and the destructive interference of these two you can say like beams. So in this way we are observing that these fringes are showing us that light is a wave. It's amazing. This horizontal line with the equal, you can say like one is the point, that's the source, you know, this laser diode source, but there is not that source alone there. If you pass it from a single slit, these you can say horizontal pattern gets off. I'll show you. Now it is passing from a single slit. You see, this is a single slit, and what you get here is you get just a straight beam. This is the single slit. Now you see, this is what you get after passing the slits. This is a constructive and the destructive interference. You see, it's very clear. And now we move on to the 14 gauge copper enamel wire. What exactly we get? Here we see light is passing from, now we are narrowing the slits. And this is the output. It's not very clear. Anyhow, this constructive and destructive interference is the process, and we see the fringes. So here the better to see this one. This is clear. You see, light is a wave. Constructive interference, destructive interference. So it's in a particular, you can say like there's a pattern, and this pattern is there, and you see also in the camera you are seeing the whole pattern, horizontal pattern of the constructive and the destructive interference of these two beams. So that's it. So that's anyhow that we were looking for, and you can easily do the same experiment You can do the same experiment at home easily with a couple of components that you need, right? And anyhow, light itself is mysterious. Still, we are working on it, and still we need to work more to understand the mysterious nature of light that we see around us, because the whole of the system that we see around us is nothing but the photons that are coming on different frequencies in our eyes, making all the solid these solid objects. You can say like mountains, trees, you and me, everything. We just, you can say like it's a photonic world. So still need more to learn on how what exactly the light is. Light is still a mysterious phenomena. Anyway, fellows, today I tried to tell you how you can do the same experiment that Thomas Young had done in his time at your home to see the mysterious nature of the light behaving as a wave. So light is behaving as a wave. Light, according to Einstein, light is behaving as a particle. So anyhow, till so far, it's a wave-particle duality. So at the same time, light is a wave. At the same time, light is a particle. So that's all, gentlemen. Hope so. You like my this effort. I tried very simply to tell you what how you can do the same experiment at home. We call it the Young's double slit experiment. Hope so you like this video, gentlemen. And if you like this video, click on the thumbs up button, guys, and share my video with your friends, and subscribe my channel and click the bell icon so you can get my upcoming new videos. Thank you. Thanks for watching.